Muted.
Hello. So, due to the rapid increase in energy costs, thermal insulations are now becoming a more important part of each industry wherever there is some sort of heating or cooling is involved, right? So, energy conservation is now becoming a more popular subject for every industry, depending on whatever there is a little bit of electricity consumption is there, or any fuel requirement is there. Thermal insulation can play a big role in terms of energy saving or in terms of monetary saving. We can convert the energy into terms of monetary savings, right? So it's very important now to, to understand how thermal insulation plays important role in different sectors, like it may be in the industrial sector or it will be in the building sector as well. So my presentation, in this presentation, you will understand the basic working principle of thermal insulation, how it acts as a barrier of energy conservation, energy transfer, and what are the applications, what are the materials available in the market, what are the ifs and buts, what are the good materials which are suitable for the industries. So I will discuss on those things because it is entirely on the practical implication point of view. It will be a little bit theoretical explanations, then it will be mostly on the application part of it. So it has been observed that thermal insulation is one of the most cheapest and easiest method of energy enhancement for any heating cooling arrangement, right? Right here, see, this is a very simple, very cheap material, and with this we can get a very efficient, energy efficient management with implication of thermal insulation material. The simple basic heat transfer methods are there. We know everybody, we have studied it in school level, probably in the 10th or 11th standard. Heat loss or heat gain depends on three different kind of transformation of heat. Like one is convection, radiation, and uh, conduction, right? So these three method takes place when there is a difference in temperature between two surfaces or two mediums, right? There only the heat transfer takes place from hotter to colder object. That is a very simple and very common thing what we know everybody. So in case of conduction, there has to be a contact between two surfaces. There should be a solid medium. When we are talking about conduction heat transfer, there will be two solid medium in contact, one with a higher temperature and one will be a little comparatively lower temperature. And heat will transfer from one solid body to another solid body by conduction method. And after certain transformation of heat, it will come into an equilibrium. That means both the bodies will come to a same temperature. That is called conduction of heat transfer. Very simple. Then there is convection of heat transfer. For convection of heat transfer, we need a fluid medium. It may be air, it may be any liquid. So within a liquid or any fluid material, convection of heat that takes place within a circular motion or from bottom to top, something like that. It happens in air, it happens in any fluid medium, right? That is called convection heat transfer system. And then there is an the radiation heat transfer. There is also a kind of transfer of heat which don't require any medium. That is, there should not be any fluid or solid medium. Without any medium, when heat transfer, that we call as a radiation heat transfer. Like simply when we get the solar heat, there's no medium in between Earth and Sun, but the solar radiation comes to Earth. Right? So this is called radiation heat transfer. So it takes any heat transfer can be happen in three different forms. But when we talk about radiation heat transfer, we need to understand a little bit about the radiation heat transfer. What is actually radiation heat transfer? Radiation heat is basically transformed in infrared spectrum. Right? So whenever we're talking about infrared spectrum, that means it's an electromagnetic wave. We have a wide spectrum of electromagnetic wave. There is a small portion called visible light, which human eye actually sense. That is called the visible spectrum that starts from violet to red. Beyond that, beyond violet, there is ultraviolet, which we cannot sense. I mean, human eye cannot sense. And beyond red, there is infrared. That is also human eye cannot sense. See, the heat transfer takes place in this infrared region, which is not detectable by naked eye. So for that, we need a kind of sensing camera, or there are infrared temperature sensors. Now it is very common and popular. Everybody can see that there are a lot of thermal scanning happening at airports and every offices and everywhere, that some security persons are using a camera or a temperature gun to measure the temperature of a patient or any human being. So that actually, that temperature is measuring, actually the equipment is measuring the infrared radiation from the body. So you can see there are two pictures. One is a visible picture on the left side, and on the right side the infrared image of that particular area. So the hot, or wherever the temperature is higher, that yellow or a whitish color is there. See, depending on the temperature gradient, the entire image formed here within a different color texture. From that color, one can identify where is the hot spots are there or the cold spots are there. So with these images, we can identify, or we can measure if any heat loss or heat gain is happening from any equipment or building, whatever it is. So this is a very good tool for us to estimate or to find out any difficulties or faults in any equipment or measuring any system like building insulation or industrial applications like boiler leakage or pipeline leakage. Everything can be detected by using this infrared cameras. Even the same system is, this technology is used for the night vision cameras. When we call about night vision cameras, actually that camera senses the temperature differences of the object or any human beings. So even in pitch dark, when there is no light, there also a night vision camera works, because it don't sense any light. It senses only the temperature gradients or temperature differences in the environment or anywhere in the world. So these infrared cameras are very common tool for measuring temperature of an object. Right? Now the simple thing is, what are the basic formulas or what are the calculation methods of heat transfer? So this is also a very initial grade, formula we use till date, that is known as Stefan-Boltzmann equation. Right? Heat transfer from any two body from different temperature gradient. The basic concept of heat transfer calculation is the difference in temperature of the two body, that is hot surface to cold. Q is the rate of heat transfer, and we call about Q by T actually. The rate of heat transfer is Q by T. K is the thermal conductivity of the barrier. This is the most important character or important properties of any thermal insulation material. Based on the K value or the thermal conductivity value, the performance of any insulation material should be judged. So whenever we are going to select any product for insulation purpose, the basic requirement to take care of the thermal conductivity value, because based on that we can actually calculate what thickness is required to achieve a certain level of heat loss or heat transfer. So K value is thermal conductivity value that is measured in kcal, or it can be in watt per meter Kelvin, something. There are different kind of units there for K value, or thermal conductivity value. And the most important thing is area. Thermal heat loss or gain or heat transfer is directly proportional to the area of the surface, right? If the area is more, the heat loss or heat gain will be more. So area is most important in case of calculating the heat loss or heat gain. Okay, fine. So the next thing is the difference in temperature. As I said, T hot and T cold difference in temperature, and the thickness we are applying for the thermal insulations, right? That is very important. So this is the basic formula which we have studied in schools or colleges, right? But in practical, which is not covered in the school or college curriculums, that there are a lot of other things we need to calculate whenever we are calculating the heat loss or heat gain. Those are like what about the air movement on the insulation surface, right? What are the color and texture of the insulation surface? Whether it is vertically oriented or horizontally oriented, whether it is exposed to solar radiation or not. So these are all actually a guiding factor of thermal insulation, heat loss or heat gain. So whenever we are calculating the heat loss or heat gain only based on this formula, we cannot actually get the exact results. So we have to consider these factors like what are the air movement surrounding the insulation, what are the color or texture of the casing or insulation cover, whether the orientation. See, I will explain that what are the implications of orientation of the equipment or system and exposure of the thermal radiation. So to take care of all these things, there are a calculation or different modified formula we are now using that is called Fourier equation, Fourier three-dimensional heat flow equation. Here in this formula, we have only considered the conduction heat loss, right? K value is basically a solid medium, thermal insulation of the solid medium, and whatever the heat is getting transferred through that insulation, that is basically a conduction heat transfer. So in this formula, we are only considering the conduction heat loss. But as we understand or we know that there are two other forms like radiation and convection. Whether we are not considering those two factors in the previous formula, now we are going to implicate these two factors in the formula again. So what will be the final formula? So in that case, I'm just explaining this. You can see this is a small. This is actually it's not working in proper way. If we consider there is a heat, you can see the at bottom where it has been written at heat. That means there is a hot surface or hot body. Over that we have put an insulation, and above insulation there is a cladding or covering over there. So every insulation material should be covered with some sort of solid or protective material that is called the insulation cladding things. So I will explain what are the cladding material available in the later stage. So whenever the heat from the hot body transfers to the insulation material, that because of the conduction heat loss, the quantity of heat that is coming out through the insulation, because any insulation, whenever we are putting insulation, that doesn't mean that we are 100% protecting the heat transfer. There should be always some sort of heat transfer depending on the thermal K value or the thermal conductivity value of the insulation material. So some sort of heat will definitely come out through the insulation at the top of the cladding material of the insulation covering material, right? So from that, from the insulation surface, the heat loss that will actually happen when the radiation heat loss and the convective heat loss will take place. On the surface of the cladding material, due to the wind velocity, convection heat loss will happen. From the surface, due to the wind, some sort of heat will dissipate in the environment. That will be the loss actually. The quantity of heat that will be dissipated in the environment because of this wind velocity, the same quantity of heat will again come from the hot body to the surface of the insulation. Similarly, there will be some sort of heat loss due to radiation effect on the surface of the cladding material. And there, this surface emissivity factor we call, that is what the texture or glossiness of the surface. The more the glossy surface, the less the radiation heat loss, right? So you will notice that whenever there is an insulation, there is a covering material called aluminum, glossy aluminum sheet. We always try to use glossy materials on the insulation surface to reduce the emissivity factor of the material so that the radiation heat loss should be reduced. We wrap food items with aluminum foil just to keep it warm for longer time, because the aluminum foil has a glossy surface, and since it is a glossy, its emissivity is very less, so it will radiate less heat into the environment. So the product will remain hot for the longer time. So that is the idea of using a glossy surface on the insulation. So depending on these two factors, emissivity and wind speed, the actual heat loss from the surface. So we called it surface heat transfer coefficient, right? Surface heat transfer coefficient is mainly deciding factor of insulation of heat loss from insulation surface. So the more these factors, the more the heat loss. The quantity of heat that will dissipate in the environment, the same quantity of heat will come out from the hot body. So that will be the loss actually. So we have to calculate these two factors with the formulas given in the IS. I am just referring you the IS factors. So this is the formula. Now you can see the final heat transfer coefficient we are considering, F, which is the radiation factor and the velocity of wind factor, right? You can see there is a E factor, that is the emissivity value of that particular cladding material, and here V is for the wind velocity, what we are considering for the ambient wind condition, right? So the other factors you can see, this 4.876 or 10 to the power minus 8, these are all constant figures. They derived from the actual experimental data. So these has been formulated implementing the systems, what will be the heat loss we have to calculate. So these are all experimental data, and based on that, these constant figures have been come. This is known as Fourier three-dimensional heat flow calculation method, right? So there is a specific guideline. It's a very important IS 14164. So these IS actually guides us for calculating the heat loss in case of an industrial application. And they have given us some guideline, like for bright aluminum sheet, what should be the factor of emissivity. For GI sheet, if we apply GI sheet, what will be the emissivity factor? And if we use, say, in case of, we have seen in many cases, people use cement plaster as a cladding material over the insulation. So these are the factors, and you can see the more brighter there, the lesser the heat loss. I mean, what per meter square Kelvin is the heat loss from the surface, or the heat transfer coefficient from the surface. So you can see the brighter aluminum is the lesser value of heat transfer coefficient. That means it will allow less heat to transfer from the hot body to the ambient. And there is another important thing. So this is the film coefficient calculation method. See, what are the factors? What are the formula we use for the film coefficient or surface heat transfer coefficient calculation? And this is now the modified formula of heat transfer, considering the F factor, or the surface heat transfer coefficient factor, right? Here we are putting the F value to calculate the actual heat transfer coefficient. Now there is an interesting thing, that for a flat surface we are using one formula, and for a cylindrical or pipe we are using a different formula, where there is a logarithmic factor is there. Now the reason behind this is, whenever we are putting insulation on a flat surface, as I told earlier, that the heat loss or heat gain is directly proportional to the surface area of the insulation, right? So in case of a flat surface, if we consider a 1 square meter of flat surface, if we are putting an insulation on the top, the exposed surface area is also 1 square meter, right? But in case of pipe, if we consider the surface area, say for a particular diameter pipe, once we are putting an insulation on top of that, if the thickness of the insulation is, say, 100 mm, then the overall surface area of the insulation material will be much higher compared to the bare pipe surface area, right? So to compensate that, this logarithmic factor has to be implicated in the formula. So that's why there are two different formulas for flat surface and for the cylindrical surface when we are going to calculate for any particular system or the heat transfer calculation. These are the basic formula and the very simple formulas we have to use, right? So the main criteria is to focus on the film coefficient or surface heat transfer calculation for the F value. Now the very common question comes to us, like, what should be the economic thickness of insulation? If we keep on increasing the insulation thickness, so it is obvious, it is a very common question, that at certain point there will be no heat loss. The more the thickness of insulation, the lesser the heat loss or heat gain. So if we keep on increasing, then there should be at one point there will be no certain condition that there is no heat loss. Then everybody will try to adopt that thickness to minimize the heat loss and the financial losses, right? But it is not that. actually what happens, I'm telling you. See, whenever we are increasing the thickness of insulation, we are increasing surface area as well. In case of flat surface also, so when we are considering the insulation surface only, but there are the periphery surface also. Okay? If I am using a 1 square meter insulation of 50 thick, then the 50 thick surface area is also there from where insulation and heat loss will also take place. So if I keep on increasing the thickness, that area is also increased. So this graph will explain nicely what should be the optimum thickness for any heat loss heat gain calculation. Whenever we are going to calculate the heat loss heat gain, this graph what should be the optimum thickness or economic thickness, right? See, if we see the insulation thickness in this x direction, that the insulation is increasing, and y as the heat loss quantity is measured in that way. So when we're increasing the insulation thickness, this red line actually, this red one shows that the cost of heat loss, right? When I'm increasing the insulation thickness, the heat loss, cost of heat loss is drastically reducing. But after certain time, even if I'm increasing the thickness, you can see this red line. This red line is that, so the stiff decrease in the cost of heat loss, sorry, is not happening after certain thickness, right? Then if we plot another line, that is H plus 1, that is the total cost of heat and insulation cost. And if I am increasing the insulation thickness, that means I am increasing the cost of insulation as well. So when we are increasing the cost of insulation as well as we are increasing the cost of heat loss, so combining these two, when we plot another graph, this black line, this is this H plus I, you will find there is a distinct dip in the curve, right? So the bottommost curve, that particular thickness, it is the optimum thickness at which the maximum benefit we can get. So that is the basic criteria of calculating the optimum thickness or economic thickness, so that beyond that, the system will not be economical because the cost of insulation I have increased and the effect is not that much. So this is the guideline of deciding the thickness of insulation, which will be optimum or economic thickness. Then another factor comes, the insulation material selections. There are different kind of insulation materials are available in the market. Now, while selecting the insulation material, what should be the deciding factors? As there are different kind of materials having different properties. So, what are the basic important properties which we have to be careful about selecting the insulation material? Right? First of all, whether those materials are following any particular standard, whether it is an Indian standard or it may be an American standard or British standard, right? Because these standards are very stringent in designing the materials property. So when any insulation material that conforms to any particular standard, that gives a quality certificate. Right? So this is the basic foremost criteria for deciding or selecting any insulation material. Then the operating temperature range, whether that particular material or insulation, whether that is suitable for the temperature where I'm going to use that material. So I'm using a material at say 1000 degrees centigrade temperature, but its withstand temperature is maybe up to 500 degrees centigrade. So it will be suitable or performing well at that particular temperature, right? So we have to be careful about selecting when the operating temperature of the system and the withstand temperature of the insulation material to be checked. There were basically a lot of handmade mattresses were there. I mean, insulation mattresses were there, but those are very poor quality. Still, those materials are available in the market, but the consistency of the material was not good. So we must avoid these handmade insulation products. These materials have to be a proven service record. So whenever there may be a lot of new technique, new insulation materials are coming, which is not time tested or proven. But new materials may be good, but we have to be a bit careful whether there is a time tested material or there. If it is there, it's better to go for a time tested material. Then these are other important factors are like water repellent grade. because whenever we are going to use an insulation material, the base material, I mean, on which maybe it on a pipe or any metal surface, if the material is not water repellent grade or waterproof material, if it absorbs moisture or water, it will corrode the mother surface, I mean corrode the pipe or the metal surface. So we have to be careful about selecting the material, whether it is water repellent or water resistant grade material or not, whether it is corrosion resistant, because in big industries like power plant refineries, there are huge pipelines or boiler areas. If those materials get corroded, then there will be huge loss. There may be a accident, chances of accident due to the leakage of steams and something like that. So corrosion resistant materials are also very important. Then comes whether it is fireproof material or non-combustible type material. See, non-combustible material means when we talk about combustibility, there is a test method, combustible test method. See, like if we use paper, if we burn a paper, that paper will start flaming. Now, if you put that paper in a container and allow the fume to come out through a particular point, particular hole, see, when the paper is burning, there will be some fume, and that fume will come out from a container on the top of the container. And if we try to put a fire on that fume, and if that fume gets fired, that means that is not a combustible material. But if the fume don't get fired, that is a non-combustible material, right? So it's non-combustible and non-ignition is a two different thing. The material may be get fired and may burn, but the fume is generating by that burning material. Whether that fume is getting fired or not, that is most important. In many cases, it has been seen in case of any fire incidents, when the material is burning, that will not harm much if the fume gets fired. That because the fume will, propagate throughout a building, through the ducts or through the openings of any window. So the fume actually generates the fire in a bigger way. So it is very important to go for non-combustible type insulation material to minimize the fire hazard, right? And of course, then durability comes into picture, whether it is a long durable material or not. So durability is another important factor. And since we talk about the green material or green product, so it is now also a big criteria whether the insulation products are green or not. Green in the sense whether the manufacturing process of insulation material, whether that process is a green process or not, that is more important to know. So it may vary depending on the vendor to vendor or manufacturer to manufacturer. So depending on their manufacturing process, they can claim whether these products are green products or not. But now this IGBC or GRIHA, this green building rating systems, they actually recommend the products which are green products or not. So there are green certifications from GRIHA for different kind of insulation materials are also there. So there are different type of insulation materials available in the market. I will go through the basic and the most common insulation materials available and which are more widely used materials, so that you can understand the facts required for this insulation system. This is the most common and widely used insulation material, most cheapest insulation material. Throughout the world, this material is being used. That is known as rock wool insulation. Rock wool, as the word suggests, that it's made out of rock. It's called basaltic rock or volcanic rock, right? From the volcanic rock, by melting the volcanic rocks at around say 1800 degrees centigrade, there are from the molten rocks we get fibers. We get very thin fibers out of that rocks, and bonding those fibers with some sort of resin called phenol formaldehyde resin, just to binding those, use as a binder to bind the fibers, rock fibers, into a different form. You can see this picture. So this is basically a slab form. This is in the slab form thermal insulation product, and it can withstand up to 750 degrees centigrade continuous exposure. So wherever there is a system, maybe a boiler or steam line, this is the most common and the only product available in the world for widely applied things. Right? There are other products for high temperature applications beyond 750 degrees centigrade, there are also products. This rock wool insulation comes in different forms. Like this is for pipe insulation, preformed pipe insulations are there. So it can be readily applied on the pipe. They are in the mattress form also. This rigid slab actually used for any flat surfaces. And if there is any curved surface, then this kind of mattress or roll form insulations are used. So this is basically used for hot insulation up to 700 degrees centigrade, or it can go up to 800 degrees centigrade also. Right? For hot applications, we use this rock wool insulations, and widely for all steam lines, boilers, there are these insulation materials are used. Beyond 800 degrees centigrade, within 800 to 1425 degrees centigrade maximum, there are another product called ceramic fiber. The ceramic fiber is made out of aluminum silicate oxide, so not silicate, aluminum oxide. Silicate is a little bit mixed down there. Al2O3. Al2O3 is the basic material forms. So same thing. Out of those Al2O3, we from the molten aluminum oxide, we extract fibers out of that, and then with a suitable binder, we make it in a different format, right? You can see there is a slab form, again the mattress form. So there are different kind of forms are available for ceramic fiber. These are mostly used for furnace lining, right? Furnace lining in the sense wherever there is temperature more than 1000 degrees centigrade, and it varies between 1000 to 1400 degrees centigrade. So within this temperature range, this ceramic fiber insulation is mostly used insulation in this, in different. It comes in different form, and you can see again there is a module form, there is a paper form, there is a thick sheet form. So there are different forms are there for different kind of modules, like with the blankets or with the slabs with a different layer. So in case of say 1400 degrees centigrade temperature, the thickness of insulation or thickness of ceramic fiber goes around say 300 millimeter or maybe beyond that. So with that, we manufacture the 300 mm this kind of ceramic blocks to use inside the furnace lining. I'm just showing some pictures of ceramic fiber lining inside a furnace. These are all oil-fired furnaces, right? You can see at the bottom there are some holes. You can notice this holes there. From these holes, actually gas-fired burners are there. The fire comes inside these holes, right? And the insulation material actually maintains the temperature inside, and the outside surface temperature should not go beyond 60 degrees centigrade temperature. Even the inside temperature is more than 1400 degrees centigrade. The outside of the insulation of the boiler casing, there the temperature maintains at around 60 degrees centigrade, because more than 60 degrees centigrade is not allowed from this personal protection point of view. So beyond 60 degrees centigrade, our skin may get damaged, right? To ensure that, the guideline says that any hitting object surface temperature should not be more than 60 degrees centigrade. So it has to be designed in such a way that thickness should be selected in such a way that the outside surface temperature of the insulation should be less than 60 degrees centigrade. So these are some applications I'm showing you for furnace lining with ceramic fiber type of application insulation. Then comes the cold applications, right? In case of cold applications, the previous two materials, rock wool and ceramic fiber, those are all fibrous material, right? The fibrous materials have a common tendency of absorbing moisture because of the capillary actions or the surface cohesion, adhesion cohesion factors. A small drop of water can percolate inside the insulation a long distance, right? So one sort of leakage water inside the insulation can create a lot of damage inside the insulated surface. So whenever we are considering for cold application, because in case of cold application, there are always chances of condensation, right? Whenever we use some sort of cold water or ice on a glass or any container, you will find there is a condensation on the outer surface, right? So same thing happens when we are using insulation on any cold application, right? It may be the chilled water pipelines. It may be any cryogenic lines where the temperature goes up to minus 200 degrees centigrade. So there, if insulation is not proper, chances of water condensation or moisture condensation on the surface of the insulation is very common. To avoid that, if we use any fibrous material over there, it is 100% chances are there that the moisture or the condensed water will percolate inside the insulation and go up to the surface of the insulated surface, right? And it will corrode the metal pipe or this surface of the insulated surface. So to avoid that, there are main insulation material called PUF, polyurethane foam insulation. I will show you how polyurethane foam actually forms. This is a foam, and foam, it becomes foam when two component of liquid comes in contact with the air. Sorry, it starts foaming, right? So that's why it's known as foam, polyurethane foam. Polyol and isocyanate are the two chemical. When it combines in presence of air, it starts foaming. That's how the manufacturing of the process, this PUF insulation has been done. So it also comes in different forms, like it comes in the slab form, it comes in the two hub pipe section so that it can be easily placed on the pipe insulations. So to avoid any chances of water ingress through the insulation material, so we always prefer to add a vapor barrier or moisture barrier between the insulation and the cladding material. Every insulation material has to be covered with a cladding material or a covering material to protect the insulation from any mechanical damage. Right? So as I said, brighter sheet having a lesser emissivity factor. So we always prefer to go for a bright aluminum sheet as a cladding material of insulation or any insulation product. So that is why we use aluminum sheet. Here in case of cold insulation, we add additional layer of vapor barrier. It may be a rubberized sheet, it may be aluminum foil, which can act as a very good vapor barrier. That in any case, if any moisture is forming on the surface of the cladding material, that will not go to the insulation surface. To avoid that, we always use a vapor barrier in case of cold applications. This is the latest insulation product has been developed, and it's not so popular till date because of high cost. But this is known as microporous insulation. Right? Microporous insulation having a wide range of operating temperatures starting from minus 200 degrees centigrade to 1000 degrees centigrade. So whenever we are discussing different products for different temperature, as well training rock wool, ceramic wool, puff, but microporous insulation can withstand or can act in a wide range of temperature. And at the same time, the thermal conductivity value is almost 1/10 compared to other three products, as I said, ceramic fiber, rock wool, or glass, puff insulation, right? So it is very high efficient insulation product. If I need 100 mm thickness of rock wool for any insulation system, microporous will require only 10 mm thickness. So you can understand the impact of the insulation. But the cost is abnormally high till now, so it has not been popular in that way. So wherever there is a space restriction, wherever there is a wherever there is a space constraint, we use microporous insulation because the cost is a very important factor here. So microporous insulation is a new product.
Mr. Chowdhury, just a second. I'll just mute everybody. There's some, I think, background noise which is coming up. Can you hear me, Mr. Chowdhury?
Yes.
1 second.
Yes.
You need to unmute again. Yeah, please go ahead, Mr. Chowdhury.
Thank you. So this microporous insulation may be a future insulation because of its very low conductivity value and flexibility in terms of different wide range of temperature of application. So in future, probably this will be the ideal product for any kind of insulation. And presently, there is no manufacturer in India, but we're importing this product from Germany. So this is a very efficient product, but hopefully it will be the cost will come down in time. As well as telling cladding material is also very important for any insulation material, because the life of insulation material depends on the cladding or the covering material. The most popular cladding material is aluminum sheet. The reason behind is its glossiness is good compared to GI materials, though GI is comparatively less costlier than aluminum sheet. But from the heat loss point of view and longevity point of view, aluminum sheet is the most popular cladding material for any kind of insulation system. You can see for any, if you visit in any refinery, petrochemical or power plant, you will find huge pipelines with insulation, and only you will see that all the things, all pipelines are covered with aluminum sheets. So this is the most common cladding material for insulation. There are different kind of color-coated sheets. GI sheets are also coming in the picture because of its aesthetic as well as the strength of the sheets. Because in case of aluminum, the problem is the strength of mechanical strength of the aluminum is not much compared to the GI sheets, but the life of the sheet is much better compared to GI sheet in terms of corrosion point of view. But if we use color-coated GI sheets, that will add as a stronger sheet compared to aluminum sheet. But because of its color, it will give us some life, extended life compared to the normal GI sheet. But we are compromising the emissivity factor. There will be some sort of extra heat loss from that. So there is an economics of using this kind of sheet where it is required, mostly in cases where the pipelines are at the ground level. There are chances of foot traffic. I mean, in many industries, we have seen that people used to walk on that pipelines because maybe there are 2-3 pipelines going. One pipeline is a plain water pipeline where it needs to be painted regularly. So there, what happens? People sit on the insulated pipe and walk for the, paint the uninsulated pipe. So the chances of damages are there. In those cases, aluminum sheet will not suitable because it cannot take the human foot traffic load. So it's better to go for GI color-coated sheet in that particular cases. There are some cases where pipeline goes below the trench. It goes through the trench or below the earth surface. There, neither aluminum sheet nor this color-coated sheet will work. There we use HDPE cladding, high-density polypropylene sheets. These high-density polyethylene sheets are good cladding material for underground piping. In many cases, many plants you have seen chilled water pipelines for HVAC system are underground pipeline. Their normal insulated sheet with aluminum sheet will not work actually. So there, these HDPE cladding sheets are used. These are totally waterproof system. Right? In case of aluminum sheet or GI sheet, there will be overlap, joints, screw fixing. So chances of water seepage will be there always. But these HDPE sheets, these are hot welded. Once I wrap the insulation, we'll just use a blowtorch to seal the joints. It will be a 100% waterproof sealing system to ensure that there will be no water ingress in the insulation. So for underground pipelines, there are this HDPE cladding sheets are there. Right? So in industrial application, if you visit in any plant wherever there is some sort of heating instrument are there, like if it's the furnace, if it's the boiler, in case of particularly I'm telling in case of any refinery, if you visit any refinery, you will find there are boilers are there, furnaces are there, heaters are there. So insulation is everywhere there, and all over the insulation you will find this kind of aluminum sheets. Actually, in case of those who are not aware about the insulation, so they will not understand what is there actually inside that material. But it is always, in case of power plant, refineries, petrochemicals, it's massive use of thermal insulations are there. Right? These are some pictures you'll see. I was just showing the people, those are working. You can see they're using a heat shield while they're working on the live lines. These pipelines are almost working. Operating at around 540 or 550 degrees centigrade temperature in case of power plant, the superheated steam temperature goes up to 540 degrees Celsius. Right? So this temperature, in case of a running plant, when we are working, the people used to wear this kind of protection shield to work on the live lines. Right? In many cases, when the maintenance work goes on, they cannot take shutdown for the plants. So we have to work on the live lines. So that is the very difficult jobs for the installations to working at that high elevated temperature. So there are some preformed, tailor-made insulation system for valves and flanges. In any system pipeline, the valves and flanges are kept open. There is no insulation formed. So this is a very common practice for any industry. So to minimize, because in case of a big plant, if there are say 100 such valves are there, quantity of heat loss from those valves or flanges are quite high. So there are this kind of tailor-made systems have been developed to minimize the heat loss from the open valve of flanges. The reason people don't use insulation on valves and flanges because frequent maintenance is required for those valves and flanges. So once the maintenance worker goes, if they found insulation material is there, they actually don't want to touch the insulation material because this kind of fibrous insulation materials has some sort of itching sensation, right? If we touch the insulation material, there will be some skin erosion or something like that. So mechanical people don't want to touch those insulation materials. So it is better for them to keep the valves of flange open. But this kind of tailor-made, openable sort of insulation pads is very easy to wrap on the insulation, valves or flanges, and it is very easy to open and again and again. So these are the systems we have developed to use for valves and flanges. This is for turbine insulation. This is a big turbine. This is almost 600 megawatt turbine. You can see this insulated plant. Earlier, there was a very bulky insulation system with rock wool, spray applied. These things are there. So those are a very messy system and not efficient in that manner also. But these are now the developments are taking place. Pre-insulated slabs or pre-insulated pads, insulation pads are there, and you can see the nicely stitched over the surface, and it can follow the surface of the turbine properly. So these are the developments now taking place in different industries. So that the ease of applications are becoming more and more compared to the previous type of applications, right? This is one called pre-insulated PIR duct for HVAC system. Any industries or even building insulations also, HVAC duct is a very important part of any centrally air conditioned building. So earlier there was GI ducting and then insulation system on top of that. This was very common, and till date there are a lot of projects are going with the traditional system. But this is a new development in the HVAC system, that is pre-insulated PIR duct. The entire duct can be fabricated with insulated puff panels, right? These panels are made out of puff or PIR. PIR is a superior quality of puff. Polyurethane foam is more known as puff material, which is not fire safe in that way. So there is a small changes in chemical that is known as PIR, polyisocyanurate foam, that's having a better fire performance. So in case of building applications, when we are using HVAC ducts, there we should not be allowed to use any material which is fire hazard. So instead of puff, we are using PIR slabs with both side aluminum foil lamination, right? The picture what you are seeing, there is a puff slab. It varies between 20 millimeter to 30 millimeter thickness, and both sides of that slab there is an aluminum foil embossed on that. So this system gives us a system of ducting system that don't require any GI fabrication. These puff panels are self-sufficient to form the ducting of different dimensions. There are specific benefits of this kind of duct surfaces because of the aluminum surface finish. The air quality is much better compared to the GI segments because the growth of fungal germs inside the ducting system is lesser in this particular system compared to the GI ducting system. The jointing between the two ducts called the invisible flange system that ensures the system is very efficient to ensure any leakage of the ducting joints. In case of GI ducts, it is very common phenomenon of leakage from the ducting joints. This PIR thermal panels having a very high thermal resistance, so the energy efficiency or the temperature drop is very less compared to the GI ducting system. And these are very fast construction. There are CNC machines available as per the GI. The drawings. The machines will cut the GI puff panels very nicely, and the fabrication time is very less compared to the GI fabrication system, right? And of course, the aesthetic part of these ducts are quite good compared to the conventional GI duct system. So you can see the finishing of the ducts very neat, and it can be exposed ducting system so that you don't require any false sealing to hide the ducts. So since the ducting aesthetic is good, so people now using these ducts as an open duct system instead of going for any false sealing. That again reduces the cost of the system also, and it is so lightweight that you don't need any more workers or labor to put the ducts on the surface, the building. So the advantages that compared to the conventional system is quite high. So these are mostly what I was talking till now was mostly in the industrial sector, but obviously in the building sector also. Now particularly I'm coming to the building applications, because nowadays building insulation has been becoming popular very rapidly. In countries like us, in tropical countries, we are not familiar with building insulations compared to the cold countries. If we follow the building codes in other countries or cold countries, there it is mandatory to use insulation for the buildings, because the heating arrangement they need to use in the buildings is a very energy efficient system, and without insulated buildings they cannot sustain because the heating cost will be abnormally high. So it is a very common factor in case of cold countries that buildings are insulated. But here in this tropical country, this concept is not that much popular. But now there are a lot of guidelines are coming, because the energy savings and energy conservation systems are becoming popular because the electricity costs are going high. So we need to adapt this insulation build for buildings. See, I'm just sharing a few things. If we consider the old buildings, if we see the British structures, if we go inside, there are a lot of buildings in Kolkata. British buildings are there. The wall thicknesses are quite high. The roof heights are also quite high. Because of that, even there is no insulations, but the inside temperature is quite comfortable compared to the present day constructed buildings, right? Now the buildings are becoming with much lesser wall thickness. The ceiling heights are also lesser compared to the old buildings. So the heat transfer from solar heat is quite high compared to the old buildings. That's why the requirement of insulation for buildings are coming into picture nowadays, right? There are quite clear benefits of using building insulations. Direct benefits are occupants comfort. Even if there is no air conditioning, if you are not going for electrical consumption calculations, from simply comfort point of view, building insulation is quite required in such warm and humid conditions. And of course, wherever there is an air conditioning system, insulation will definitely add in reducing your energy bill, right? So it has been calculated that in case of a building insulated on top and walls, will reduce your electricity bill up to 30 to 35%. So it has been already proven by different agencies that thermal insulation can give that much of efficiency in case of energy savings point of view. And there are some indirect benefits, like whenever we are using thermal insulation that are obviously an non-combustible type material, and it gives an added advantage in case of fire. It acts as a noise barrier also in case of any building which is situated inside the roadside. The noise problem will be reduced because of the insulation system. It acts as a moisture barrier also. There are a lot of insulation material when we're using on the rooftop. So it will actually take care of a waterproofing system as well. So there will be less chances of water leakages from the rooftop. So it will be a moisture barrier, and it will enhance the building life as well. So what happens when we are using insulation on the top of the building, on the top of the roof, we are not allowing the heat to come into the building structure actually, right? We are using the insulation on the rooftop, so the heat is restricted beyond the structure. So if there is no structural heating is there, due to the structural heating, what happens? The structure expands and contracts in the day and night. So there is, because of this expansion contractions, the life of the building, reduced. So when we are using insulation from the external surface, we are not allowing the heat to come into the building structure. That actually enhances the building life, right? See, in case of building insulation, it is not only helping us in the hot days. I mean, it is not only saving our electricity bill from AC air conditioning electricity bill, but in the winter also it is helping us in a different way. Like the solar radiation, if you can see in the summer, the path of the sun is such that it goes almost from the vertical portion of the top of the building or top of our head. So the direct solar radiation comes on the rooftop. But similarly, in the winter, the solar radiation or the solar incidence is coming in a certain angle. If you have noticed that the solar radiation in the winter comes through our windows actually, because the orientation of the sun is such, the angle of incidence is quite less. So the solar radiation actually comes through our windows, and it gets heated inside the building. So because in winter, when we are getting the solar radiation inside the building, the room or inside the room, it is getting heated, and that will be remain for longer time if insulation is there. Right? In the winter also we are getting benefited. At the same time, in the summer also we are getting benefited out of this insulation on the building. So to guide us and what will be the ideal insulation system, what should be the thicknesses, etc. There has been a code generated in the year 2007 that is called ECBC 2007. There are a lot of workshops and seminars organized by ISRE on this topic, ECBC 2007. A lot of modifications later on came in this ECBC system, and the latest ECBC, I think in 2018, has been developed, the latest ECBC code, and different states are modifying this code depending on their requirements. So state-wise ECBC are also different. This code actually guides us what should be the, not only insulation, there are a lot of other aspects are also there in case of glass glazings, in case of water harvesting, whatever the energy efficient buildings practice should be, that has been guided in this code. Insulation is one part of that. Whenever we are going for insulated building or energy efficient building, there are now a rating system of the building also, right? Like star rating. In case of electrical appliances, we go for rating system, for star rating system. Similar rating system is also applicable in the building sector as well. So to achieve a gold rated building or a platinum rated building, certain number to achieve, like out of 100, if we can achieve 90, then we can go for gold certification, something like that. There are almost 34 different points, starting from water harvesting, solar lighting system, gardening, tree plantations, in thermal insulation applications. So there are different points are there, and based on those points, how much one building is scoring, depending on that, that building will be rated. Their insulation marks is 9 points out of 100. So it carries a good amount of point if we use insulation in case of building construction. So whenever people think about certification of their building, insulation can carry a lot of marks to achieve certain rating of the building, right? This ECBC code has been divided the entire country in 5 different climatic zones. There is hot and dry, warm and humid, composite, temperate and cold. So these 5 climatic zones, they have divided the entire Indian contour. And based on these different climatic zones, they have guided us with different kind of U value or R value. I'm just telling what is the U value and R value. I mean, there are 2 kind of buildings are there. One is 24-hour use building, that is hospitals, call centers, like this kind of buildings. Those are 24-hour use building, hotels. And there are some 12-hour use building like offices, schools, shopping malls. These kind of buildings are say considered as a 12-hour use building. So when there are 12-hour use building and 24 hours building, ECBC has guided us for different composite zones what should be the U value or R value of the walls and roofs, right? U value means thermal transmittance factor and R is thermal resistance factor. So it is just inverse. R is equal to 1 by U or U is equal to 1 by R, whatever it is. So if we know the R value, we can calculate the U value as well. R is L by K. L is the thickness of the insulation and K is the thermal conductivity. So whenever we are telling about the thermal resistance of any particular insulation, we have to calculate it as L by K, thermal insulation thickness divided by the K value of that particular thermal insulation. So what is the thermal resistance we have to achieve for a particular building, for a particular composite area? That has been guided. So this is the fact, I mean, figures we can get from the CBC 2018 now, it has been modified. So for particular area, if Calcutta comes around hot and humid, warm and humid zone. So if we are constructing any building here, so we know, if we know whether it is a 24 hours building or a 12-hour building, then we can easily calculate what should be the thickness of different insulation material. So if we are going to use rock wool, what should be the thickness? If we are going to PIR or puff slabs, then what will be the thickness? And there is a spray method. I will show you a video, small sort of thing that will be clear for you. So these, based on these insulation products, we can actually calculate the thickness of insulation required for a particular building, right? So this is how for building insulation we can get a clear guideline of thickness and material to be used. So it has been observed by a study. See what is the actually, in case of if there is no insulation and there is no air conditioning system, even what advantage or what benefit we can get out of this insulation material. So we have measured the temperature of a building having a roof of say 150 thick roofing system with 150 thick of brick walls at 10 to 12 ambient temperature. When the ambient temperature is 39 degree, I mean the outside temperature is 39 degrees centigrade, the rooftop temperature goes around 45 degrees centigrade. Right? You might have noticed this bituminous coating on the road gets melted at peak summer, right? When the ambient temperature goes around say 45, 46 degrees centigrade, you will notice that the pitch on the road is getting softened. But to soften that pitch or the bituminous coating, it needs around 70-75 degrees centigrade. So that means even the ambient temperature is 45 or 45, 46 degree temperature, the surface of the road has reached around 75 degrees centigrade. Similarly, if the ambient temperature is 39 or 40 degrees centigrade, actually the rooftop surface temperature goes around 45, 46 degrees centigrade, right? And at the bottom of the roof, just below the rooftop or the ceiling of the building, if you consider from the inside, the top of the ceiling, the temperature is around 35 degrees centigrade. And at the floor level, that temperature is around 31 degrees centigrade. Right? So this is for a uninsulated building I am telling about, right? Sorry, I'm just mistaking. See, if in case the green color temperature is showing actually the temperature at the bottom of the roof, and the red color temperature is showing the temperature at the working floor temperature after roof insulation. What will be the temperature will come around. So there will be a clear difference of around 5 to 6 degree temperature compared to the ceiling temperature to the floor temperature, right? So with insulation, we can achieve around 5 degrees temperature drop compared to the ambient temperature, not ambient temperature compared to the ceiling temperature, because that heat is coming inside. No? So that's why we feel warmer in case of an uninsulated building. Now there is a very common question that if we use insulation, then how much temperature drop we can achieve? But this is a very tricky question because it is difficult to exactly, there is no proper calculation method of how much temperature drop will be there, because it depends widely on the ventilation of the room. If the room is not properly ventilated, if there is no air movement inside the building, the temperature inside the building may rise beyond the ambient temperature. Even if the temperature outside is 39 degrees, if there is no ventilation in the room, then the temperature may go around 40 degrees or 45 degrees. So proper ventilated room, there we can estimate, or there we can achieve a 5 to 6 degree temperature drop compared to the ambient temperature. Again, there are different insulation materials, like as I said, raw cool insulations, polyurethane foam insulation, even thermocols or EPS, expanded polyester. I am not covering EPS here because EPS is not at all a fire safe material compared to the polyurethane foam or raw cool insulation. So for building insulation, EPS, though EPS is or thermocol is much cheaper compared to raw cool or polyurethane foam, many applicator uses thermocol inside the building, but it is strongly not recommended to use thermocol from a fire hazard point of view. So it is always better to use a fire safe material whenever we consider about building insulation, particularly from inside the building, right? So that is why I'm not considering polyurethane puff insulation product in this particular presentation. See, these are some comparison. I'm just showing you what are the different properties of different materials. And another important aspect is what is the use of the waste material of an insulation material. So if the waste is hazardous for us, then it will be very difficult to handle those products, right? So it is always, whenever we consider for insulation material for building particularly, it should be always a safe material, for the personal protection point of view. Then another factor comes into consideration while selecting insulation product. Like there are, say, 3 kind of insulation material available in the market. All are equally cost-wise equal, all having a good property of thermal insulation, thermal conductivity value. Then which product should be used for a particular project to get better marks in terms of energy conservation point of view? There, this embodied energy concept is coming, because I am having 3 options, 3 materials having equal property, cost-wise also equal, then which product should be selected? Then this embodied energy concept comes. This tells us during manufacturing of those products, which product uses more energy during manufacturing, right? So that is known as the embodied energy inside that building, inside that product. So if any product which is using higher energy during its manufacturing, that will get lesser product. So you can see here in this chart, raw cool embodied energy is lesser compared to the other products, right? Raw cool, glass wool, polyurethane foam, then expanded or extruded polyester, that is called thermocol actually, nitrile rubber. So these products are available in the market. All are equally good in case of say fire hazards point of view or thermal conductivity point of view, but the embodied energy is much lesser compared to, Rockwool embodied energy is much lesser compared to the other products. So we always prefer to use the products which is having less embodied energy or lesser embodied energy. There are some roof insulation system. One is called underdeck insulation. Underdeck in the sense when we are putting the insulation from the bottom of the roof, from inside the building, that is known as underdeck insulation. And another call is overdeck insulation. That means the insulation is applied on the top of the building, on the top of the roof. These two systems are most common application of insulation for the building roof insulations, right? For inside applications, we always prefer go for Rockwool insulation because it is cheaper as well as it is most fire safe material compared to any other product. Otherwise, there are PIR or polyurethane foam materials can be applied. At the same time, thermocol also can be used, and there's another product called nitrile rubber can be used also. So compared to any other product, it is Rockwool is the most cheaper and fire safe material for underdeck insulation. Right? For rooftop overdeck insulation, the most common and popular product is PUF spray, polyurethane foam spray applied product. There is a system called spray applied system. I'm just trying to run this video. I don't know whether it will be running or not. It will explain. Yeah. So PU or polyurethane foam spray system, it actually is a system which requires machine which actually mix the two components of the foam. One is polyol and another is known as isocyanurate. These two chemical comes in liquid form with a certain percentage of mixing, and when it comes in contact with the air, it starts foaming. It starts foaming means if I spray up, it will like a paint sort of thing, but within a second it will come over the surface and it will raise the thickness of the paint to say 25 mm or 30 mm thickness. So whatever the requirement of insulation thickness is there, we or the applicator knows how much spray I have to do there so that the required thickness can be achieved. This is the spray machine. With that, these are the two chemicals. One is polyol and the isocyanurate, and there is a compressor which actually compresses these two liquids along with air. The compressed air and two liquid comes through pipe and goes up to a gun, spray gun, right? So these three pipes are going, carrying the liquids and the compressed air to a gun called spray gun. This is a spray gun, and using those three from a one single nozzle at the same time, this three. Oh, sorry. So so this was the thing. This was the application of roof insulation with PU spray system, and finally after finishing, there will be some sort of waterproofing membrane, or there are a lot of waterproofing materials are available in the market to protect the surface from water ingress. Waterproofing treatment can be done on top of that, right? So this is how PU spray insulation is becoming popular now for any building. It may be a commercial building, it may be a residential building, but this is now becoming a popular system. And then it comes the wall insulation as well. So there are a lot of different type of wall insulations are there depending on the building and the requirement of the building. Most common and popular system is the channel form system. That is, there will be a framework. It can be a GI framework or it can be a wooden framework. And in between the two surfaces, there can be a brick wall, or one surface can be, it may be a gypsum board, or it can be any rigid board. And in between, there will be, say, 50 mm to 65 mm thickness, depending on the ECBC requirement. The thickness can vary depending on the location of the building. So there will be one, it can be brick wall. From there inside, there will be a framework, and within that frame, the insulation will be put in, and that will be covered with a rigid board. This is a very common application of insulation. and another one is known as cavity wall insulation. So this cavity wall insulation is like there will be both brick wall outside and inside, and in between there will be an insulation. Again, that can be 50 mm or 60-65 mm depending on the requirement of the ECVC. So these two common system of wall insulations are now there, and the insulation material, maybe it can be polyurethane foam or it can be rock wool insulation as well. And again, the spray application can be done on a wall as well. As I showed this video for rooftop insulation, the same wall insulation can be done with spray polyurethane foam as well. So this, I'm just showing you this photograph of wall insulation with PU spray. There's a small video also. I'll try to show that. Just a second, if I can run this video. Yeah. It's not running. No, this one. Just a second, I'm trying to run the video. Well, Samajit, is it visible?
Yes, sir. Can you just remove that below that you're getting a pop-up called, you can just put hide. That pop-up.
Oh, yes. Now I got it.
And you
Okay,
can,
fine. Is it visible now? No?
yes, it is visible.
Okay, so this is the, this basic spray. You can see how fast it is foaming. Just as a small paint sort of thing, but instantly it gets foaming and it covers the entire, hollow space. That is the requirement of the height of the thickness. So this is a very common and readily available product in the market now for any building insulations. If wall insulation is required, it is a very fast insulation process. And finally, after completing the insulation, the top will be covered with any kind of finished board, right? This is how. I'm not going to the full video because it will show how. So that's okay. So this is almost this is my last slide. So normally what I used to complete, I used to finish my presentation with a slide like this. So if we use energy efficient products to save our energy as well as to save our nature, to give a better future for the next generation, right? So thank you very much for your present sharing, and I request Shomajit to take care.
Thank you, Mr. Chaudhary. It was, I am sure it is a very, though I am into this business also earlier, so it just refreshes my memory personally. But definitely with the details which you have shared, it would be a great knowledge sharing experience and understanding for all our participants. So now I'll get into the questions part.
Yes.
Though your presentation was so simple and so well shared that I don't think there's any doubts as such. The questions are very less. So I'll just go to one of the questions which is there. Yeah. For the participants, I would request not to write their email ID. Mr. Chaudhary, can you share this presentation to us? Can it be shared to the participants?
Yes. I can mail you.
Okay, so I am
I
just
mean,
typing my
I will mail you, no? Yeah.
yeah, I'm typing my email ID on the chat box. I just did now. It's omojitbanerjee@gmail.com. So I would request you, Chaudhary, if you could just share the presentation to me.
Okay.
Then
I will
uh,
share definitely.
Sure. And I'll just close you as a presenter. Then you can, I think, see
Yeah.
the chat box better. 1 second.
Okay.
Uh, no, it's okay. I don't have to dismiss. You got my email ID, I suppose. Just go down, right up till down.
Yes, I got it. Yes, sir. Yeah, I got it.
Yes, so you can just send for the participants also. This is information to all of you. If you require the presentation, you need to have fill up the feedback form. You need to be a ASHRAE member. So if those two criteria are fulfilled, if you are a ASHRAE member, you need to share your ASHRAE membership, which you must have shared in the registration link, and you need to send your request for PPT to my email ID, which is there, somojitbanerjee@gmail.com, and then the same would the PPT would be forwarded to you. Okay, so I hope it is very clear. So feedback form needs to be filled.
So, just I want to say thanks to Gunjan sir. I think I was not sure that he was there. So I
Yeah,
think Professor Gunjan Kumar was there, right?
yeah, he was there. I'll just come to the questions, sir. He's also got a question. So I'll just go to the questions.
Yes, yes.
But before that, I'll just complete the protocols. So the
Hmm.
feedback forms have to be filled. The registration numbers have to be shared, and you have to mail it to
Hmm.
me. Only your registration number with your to my email ID somojitbanerjee@gmail.com to get the PPT. Okay, now getting on to the questions. So there's a question from Mr. Udesh Roy. For building, which type of thermal insulation we should go for? This question is you have been shared. It is a very vague question because under deck, over deck, wall, everything is separate. I'm sure the question has been answered very prominently by you on all aspects. So,
It's all right.
so maybe I would ask you on his behalf, what type of insulation should be used for floor insulation if there is a requirement?
Normally for a residential building or this kind of commercial buildings, floor insulation not required.
Mm-hmm.
But in case of say cold storages, if you think about cold storage,
Yeah.
where normally the temperature for fruit and vegetable cold storages, the temperature is normally at the plus temperature 2 to 80 centigrade temperature.
Mm-hmm.
Their floor insulation is required.
Mm-hmm.
And for floor insulation, there is a specific specification for floor insulation that it has to be moisture proof as well as it should be thermal insulation, right? So for that, the thermal insulation material, maybe it can be thermocol or EPS, expanded polyester. Thermocol is a very commercial term. The technical term is expanded polyester, EPS in short, right?
Mm-hmm.
So EPS or puff can be used with a coating of bituminous paint for floor insulation. It mostly used for the cold storage applications, right? Not for commercial buildings or residential buildings.
Okay. I have this question which is related to this, sir. Why should we use
Yeah.
aluminum checker plate in cold storages? If it is, does it
Okay.
take part of insulation properties?
Not really. Checker plates are always used wherever there will be a movement of load. I mean, whenever we carry something or we use forklifts or we carry some loads over the floor. If we don't want to damage the floor, we need a checker plate support. Right?
Okay. Okay.
It is mainly from strength or mechanical point of view, actually, no thermal insulation point of view.
I understand. There's one question from Professor Gunjan. For wall
Yes, sir.
insulation and energy efficient concrete slab, which is preferred with regards to ease of construction?
Very good, sir. Uh, there are hollow bricks or now fly ash bricks coming with different shapes and sizes. There will be air pockets entrapped inside the brick whenever we are going to use hollow bricks. Uh, Definitely entrapped air or static air having a good thermal insulation property. So in earlier days, there was a concept of roof insulation called brick bat coba. Now it is not that much of popular, but in case of roof insulation, brick bat coba was there, which actually uses some sort of porous brick, right? Using that porous brick, they use on top of the roof to ensure there are a lot of air pockets inside that, and air pockets will give a good energy, good thermal barrier. Similarly, for walls also, when you use air pockets or wires inside the brick wall, it will definitely give some sort of energy efficiency or thermal barrier. But the thing is, in present day construction, floor area is quite costly. To reduce the wall thickness, now people are trying to go for a thinner wall to get a better floor or more floor area compared to the thicker wall. These hollow bricks is comparatively higher, I mean, thickness compared to the conventional wall thickness with insulation. So if we consider a wall economical thickness, then it is better to go for a wall with insulation sort of material compared to this hollow brick system. Is it clear, sir?
Clear, sir. I think Mr. Gunjan also must have understood clearly on this, and now he's put a very good point later that saying the trade-off between insulation and energy efficiency, right?
Yes.
So that is what you have already shared also. Okay, there's one more question which is from Mr. Udesh Roy, which the question is, should insulation depend on outside and inside temperature? I think the answer is yes for both.
Yes, definitely. Yes, yes.
Because the
Of course.
delta T has to be, delta T would
Always
yeah,
the deciding factor. It is the main deciding factor of heat transfer.
exactly, exactly. Okay, there's one more question from Mr. Akshay Kumar. Sir, should insulation should always be covered with some cladding, or it can be used without any of those? I think you have already answered this question. Cladding is
Yes, it is always required to protect the insulation because insulation don't have any strength, mechanical strength.
right, right.
So if any sort of hazard is there or any chances of abusing is there, the insulation will get damaged easily. So just to protect the insulation, it is always recommended to use any sort of cladding material.
Right. There's one same the same person has asked another question. What type of insulation is preferred for cold storages?
Yes, the conventional cold storages, I mean, the 100 years old cold storages are there. The starting at the initial stage, still those cold storages are available. I have seen those cold storages. They were using wood dust, right? So wood dust was a good insulation material at that time, and the thickness of that wood dust insulation was around say 300 millimeter thickness to achieve certain level of R value or U value, whatever. So now then gradually the specification changed to thermocol or EPS, expanded polyester. 99% of the cold storages, old cold storages are with thermocol insulations or EPS insulations. Right? All the big cold storages are potato cold storages. If you go inside, there inside the building there is a 100 thick EPS or thermocol layer is there. Beyond that, they use a wire mesh. Wire mesh acts as a reinforcement for the plaster coating. So the puff cannot be left exposed to the surface because there are chances workers when they will work, they may damage the insulation system. So it needs to be protected from a cladding. There it is commonly used plaster cladding. The cement plaster of around 12 mm or 15 cladding is there on top of the thermocol. So using a plain GI, mesh, metal mesh, over that they use a plaster. So this is a very common insulation of cold storage factor. Now the new cold storages, I have not covered that in my presentation actually. Now we are using pre-insulated puff panel. It comes in ready format. There will be both side metal sheets and inside polyurethane foam. The panels comes in 1 meter width and at maximum it can go up to 12-meter height. So one such panel, there will be a locking arrangement between panel to panel, and we can construct a room within hour or two. I mean, if we construct a room of 10 meter by 10 meter by 10 meter, it will take around half an hour or 1 hour to construct a building. So this is the now latest technology for not only cold storage constructions, lot of residential building as well as construction site office, particularly in this COVID-19 situation, a lot of quarantine centers have been developed in a very short time of period. These prefabricated insulated panels, mainly developed due to cold storage application for cold storage applications, but now there are a lot of applications are coming in the building sectors. Even there is a building, if you in Calcutta, coming from Salt Lake to Rajarhat, bang opposite to DLF building. Left side there will be DLF building, and just opposite there will be a building called Restelo. The name of the building is Restelo, constructed by Sachi Group. The entire building, there is no brick wall. It is constructed only with puff panels, insulated panels. This is a G+4 residential building. So these concepts are coming in the picture of using insulated panel wall. There will be no brick wall required. Right. So these are the new trend, and particularly cold storage applications. All new cold storage is coming with pre-insulated puff panels. No brick wall insulation is required.
Okay, so the next question is, because I just wanted to share one more thing. Cold storage has got a lot of space also, so there is no challenge on the insulation part. Unlike air conditioning insulation, where hardly there is any space.
Yes.
Okay.
It's not yes, ma'am.
Yeah, there's a question from Mr. Karthik. Could you please throw some light on aero bricks or aerogel filled bricks? Are they safe for usage in residential commercial applications with occupancy?
Yes. I sold one insulation last, that is called microporous insulation.
Right.
Aerogel is a process of microporous insulation manufacturing. Aerogel is a technique. Aerogel is not the product. Microporous is the product. Aerogel is the process of sol gel technology. It's more popularly known as sol gel, sol gel technology. So that process makes this microporous insulation. But as it is not so much popular till date, because I said it is abnormally high cost is there. So it is obviously the future is that. Karthik, what you are asking, that is the next generation of insulation we are going to see in the market. But it will take another couple of years or 3. So it is safe. It is obviously safe, and it is most efficient insulation in the world just now.
Mr. Chaudhary, the next question I'll come to it. But before, I'll just talk to the participants. Participants, please note this is a technical seminar, so please do not ask any questions on commercials. That is beyond the purview of this webinar. We are not here to discuss on pricing of products, and that's the reason the speaker has not shared any of shared his company's logos or details in any of his presentation. This is just clearly a technical program. Okay, so I cannot answer to the questions of cost, or I would not prefer the speaker to discuss on these points at all. Okay, so now next question is again from Mr. Gunjan. The insulation after a certain thickness not giving significant energy savings. So generally, as per ECBC building, what maximum thickness used for wall and roof with proper trade-off with R value of ECBC requirements? Before you answer, Mr. Chaudhary, I'll share to Mr. Gunjan. Gunjan, this question what you're asking is something which is long-term wear and tear of insulation. So that generally insulation would have challenges of wear and tear with passage of time. That's the reason we are using cladding, and that's the reason we are doing so many products on top of that to prevent that. But thickness as well of wall and roof depends on the application also. And application of a cold storage, the thickness of puff panels would not be same as the pipe thickness of a air conditioning line. So it differs from case to case. I hope Mr. Chaudhary you would agree to this point.
Yeah, thickness, again, you're absolutely right. The thickness always vary depending on the application. So whenever we are considering insulation thickness, the two things are there as per ECBC, what material we are using. So depending on the thermal conductivity value of the material, thickness will vary. ECBC has given us a guideline of U value or R value to be achieved for a particular building for roof and wall. So to achieve that U value or R value, what material I am using, depending on the cable of that material, the thickness of the insulation will be decided.
Correct.
So it is right.
Okay, so no other questions, Mr. Chaudhary. Thank you for your